In this video, I'm going to be telling you the story on how I built the world's most dangerous rocket in 7 days. So it turns out that making a rocket is fairly difficult, and it's almost like it's rocket science. First, I need to come up with the most efficient method to make gas, which I could then pressurize in a test tube. Lastly, once I had exploded, I could model a rocket that I could put onto the cork, which should then go up. The first thing that I did was tested a few ways to make gases. Now, if you couldn't tell already, I was putting some sodium bicarbonate into a lid, and then I put the bicarbonate into a flask. This was going to be your classic and easy baking soda volcano experiment, just at 6 times the strength. The way that this works is that an acid called acetic acid reacts with our bicarbonate of soda to neutralize, and this should make a decently sized explosion. However, the only problem is that this explosion is from carbon dioxide gas, which makes it bad. Now, this makes it the perfect time to clarify why I'm doing this, so no one gets too suspicious or goes into the comments section and tries telling me that I'm doing something stupid, as always. This experiment was being done because I'm researching the most eco-friendly way to make a rocket. Now, the rocket in the end will use hydrogen gas, but the only problem with hydrogen gas is that it's extremely flammable. For example, take the Hindenburg disaster in 1937 when a German airship exploded. When I continued, I poured some of the acetic acid into a graduated cylinder and set that to the side. Then I began with the second reaction, which is called a redox reaction. This should be infinitely stronger than the first reaction. If you don't know what a redox reaction is, take a look at my other video, which I'll link in the description. This reused potassium permanganate, which is a lovely colour, and it reacts with hydrogen peroxide. Now, I poured some of the peroxide into a graduated cylinder, and I began with the first experiment. Unfortunately, you could tell that it didn't react very well. Now, while yes, some carbon dioxide gas was being made, and there was a fair bit of bubbling, it wasn't too significant. For the second reaction, however, this was way more vigorous. Not only did it react so aggressively, the gas that was being made here was also better. It was oxygen, and we have oxygen in our environment, which makes it way better. Problems, however, arise when I try to pressurize it into a test tube. I used a plastic test tube because exploding glass is usually bad, and I poured some of the peroxide in first. Then I followed it with some of the potassium permanganate, however, it reacted extremely quickly, and I couldn't seem to pressurize it in time. The cork didn't seem to want to explode, nor to react. So overall, this was a pretty bad fail. What I had to do next was research another way to make a gas, which I could then pressurize. However, that's where the next part comes in. Around this time, I learned about the magic of metals and acids and how they could react together to make lots of gas. I began by pouring some fairly dilute hydrochloric acid into a beaker, followed by a few chips of aluminium. Now, when I weighed the aluminium, it wasn't gonna be over a gram. If it was over a gram, it was gonna react extremely vigorously. I had to work quickly so that the reaction didn't initiate, which is why I also used dilute acid. When the aluminium reacts with the hydrochloric acid, it makes aluminium chloride and a ton of hydrogen gas. Now, the reason this reaction takes time is because aluminium reacts so much with the air that it forms an oxide layer around itself. Now, from the video, you might be able to tell that it's starting to react. There's a bit of hydrogen gas being formed, and the reaction just seemed to be getting more aggressive as time progressed. Now, one way to test for hydrogen is by lighting something inside, which is what I did here. Now, if there is hydrogen present, there should be a pop sound. Now, not only did this fit the criteria of reacting slowly, it was also vigorous enough to the point where it could make something explode. Now, if you don't think that that was vigorous enough, take a look at this. Is that just not great? I'm still fascinated by it. Anyways, it was now time to put the reaction into a test tube and see if it would explode, unlike last time. The test tube is discoloured from some iodine, however, this shouldn't be too bad. I poured some of the hydrochloric acid into a beaker first, and then into the test tube very slowly, but also confidently to prevent the surface tension from stopping me from pouring it. Then I followed it with a few clumps of aluminium, which might have slowed the reaction down due to the small surface area. However, I still had to work very quickly to stop the reaction from happening. Now, I topped it off with a cork and put it into the test tube rack, and now I just had to wait patiently while the reaction reacted. Soon after, a lot of gas was being made when all of a sudden it exploded. Now, this was a good thing. However, it was a good job that I used dilute hydrochloric acid. Otherwise, I'd have acid all over my roof and everywhere else. The reaction still kept on reacting, so we had to wait for it to calm down a bit. But I knew that now I could model the rocket and go ahead and print it out. I'm not the best 3D designer, so I might just be spewing nonsense out. However, I tried to make this rocket as aerodynamic as possible by making it pointy and streamlined. Now, I wasn't sure if this was going to work, but I tried my best, and I just modelled along with a reference image that I got from Google. I did try to make the sides curvy, however, that didn't look too great, and I just kept on modelling until I got a design I wanted. Later, however, I found a much better way of making the edges curvy, and I topped it off with some wing-like designs and lastly some text. All that was left to do was make a little hole for the cork to be put in, and lastly to go ahead and export it as an STL and 3D print it. After an hour or so, the model had finished printing, but for some reason the file got corrupt. Uh, so I can't really show you the time lapse. However, as you can see, it was very sharp. It was so sharp that I had to actually sand it down, otherwise I might cut myself from it. Now, I glued it to the cork and onto the test tube to test the fit, and it seemed to be fitting extremely well. Now, all I had to do was react again in the test tube with this rocket on, and hopefully everything should go well. And if it doesn't, I might get pissed. So I reacted the acid and the aluminium once again, put the rocket on, and stood really far back. For a while, the reaction seemed to be going perfectly and as normal, and that was until acid started spewing out from the sides. I'm not sure what happened there, but I assume it wasn't a perfect seal, and this made me quite worried when all of a sudden it just went everywhere. Now, it wasn't going to be the greatest, it's obviously homemade, but it was experimental and it might have worked with some more tinkering. If you enjoyed, like, subscribe, share,